All right, everybody, welcome to session 2, your second lesson in module A. This one's going to be about more of those measures of center that we started talking about. We talked about mean, which is one of the most commonly used ones, but we're going to talk about some more of them today. The mean, you'll recall, is the calculated average for a set of data points. So we add them up, add up all the values, and then divide by the number that we have. And the terminology that we use, the notation that we use for a sample mean is X bar. The next one is the median, and that we can think of as the middle of a list of data that's been put in order from least to greatest. We denote this with just a little bit different notation. It's X tilde. So it's got the little curvy thing at the top. And we do want to make sure that we distinguish that from the mean. Median is a middle value, and that's used in those cases where mean would not really represent the data well because we have like really big values that drag up that mean so that it's not representative, or really low values that drag up that mean so that it's not really representative. So we use X tilde when we just want the middle number to represent the data set as it's listed in order. Putting it in order is very important. It can't just be like the middle when we have it just in some random order. The mid-range for a set of data is going to be a calculated average, but we only include the largest number and the smallest number in our calculations. It's like we don't even care what's in the middle. We just take the biggest and the smallest and then take the average. So it's like the middle as a calculated average, but just the average of the biggest and the smallest values. Think for a second about whether you think that would be affected heavily by outliers or not. Would the mid-range be affected heavily by outliers? Yeah, of course, right? Because outliers are definitely going to be that really big number that's the maximum, or that really small number that's the minimum. So our set could be totally misrepresented by a mid-range if we happen to have an outlier of any kind. Mid-range is quick and easy though. It's a sort of calculated average that we can use if we know that the set is appropriate for that use. So if we have a whole bunch of values that are really similar in the space between them, in the variability between them, and they're all fairly close together, the ends are not very far away from the rest of the data, mid-range might represent our data well. That is a really important thing to consider when we're talking about statistics, because the whole point of statistics is to describe our data. So we want to be able to think big picture about what we are trying to describe, what it is that we're trying to describe. Is this going to be a good thing to describe it by? And our last measure of center is the mode. So it's a measure of center in a sort of different way from the other measures of center, in that we consider the mode to be representative of a set because by definition it is the value that occurs the most frequently. A situation where that might be appropriate is maybe in a set of school districts throughout Idaho. You survey these school districts, and most of them require 6 math credits for high school graduation. Say there are a couple like prestigious school districts that require 8. Maybe there are a couple that are special needs school districts, or they have a lot of special needs schools in them, and they only require 4. I don't have any idea if this is actually true or not. But if most of the school districts in Idaho require 6 math credits to graduate, that would be a representative value, and we'll just be like, well, yeah, 6 seems like the measure of center that makes sense to represent this amount of, or this set of data. So looking at your first problem on your guided notes, your in-class practice problems, we have a question that asks us to calculate the median and the mid-range for this set of data. So let's look at A, this first set. Well, the first thing that I notice about A is that A does not seem to be in order from least to greatest. So if I'm going to calculate a median, I have to get there first. I have to rewrite this list so that my values are in order. When I've got it rewritten this way, now it's pretty clear which is the middle value. This one's a nice handy one because it actually has an odd number of values in the set. So there is a true middle. We can just say there are 2 on this side, 2 on this side. 15 is the middle. So the median for A, or x tilde A, is 15. Seems to me that that was the mean for this set too, if I recall correctly. Now how about mid-range? Mid-range for A, it's going to help to have this set up in this least to greatest order if we're going to do our mid-range also, because of course we need the least value and the greatest value. So if I'm looking for mid-range for set A, recall that's the calculated average between, or the mean basically, between the largest value and the smallest value in the set. Mid-range then is equal to, for A, is equal to 22 plus 10 divided by 2. 32 divided by 2 is 16. So that's our mid-range. Our actual average and our mid-range are not the same. Our mean and our mid-range are not the same in this case. Think for a second about what it would require for the mid-range and the mean to be exactly the same. It seems to me that each, the highest value and the lowest value, would have to be exactly the same distance away from the mean when we began, right? All right, let's go to our next data set. B is already set so that it's in order from least to greatest. And it's different though. This set is different. It's going to be a little bit different when we're looking for the median because there's not an actual middle in this set. We don't have a middle because there's an even number of data points. So median of B, so x tilde B, that has to be determined by calculating the average, the mean, between the two middle values of our data set. So instead of having a single middle value like we did in A, we're going to have to take these two, and therefore this is kind of an interesting case too when we have an even number of values, because the median, while we think of it as the middle value in the set, sometimes it's not actually a value in the set, just like it's not going to be in this case. So let's go ahead and identify our two middle values and calculate the median. 7 and 8 are our two middle values, and you might have some intuition here. You might already know that the value that's smack in the middle, right between 7 and 8, is 7.5, but we'll go ahead and calculate it as an average. So this is going to be 7 plus 8 over 2, 15 over 2, which we could go ahead and write in decimal form as 7.5. Again, not a value in the set, but it's the median nonetheless. Okay, so just to recap, for a set that has an odd number of values so that it actually has a middle. The median is the middle value, but with a set that has an even number of values, the median is the mean of the two middle values, because again, a middle value does not actually exist. We have to take those two. Okay, now we're going to do some tricky stuff with our median and mid-range like we did with our mean, and see what generalizations, what conclusions we can draw about how scaling and adding or subtracting will affect our mid-range and our median, given that we change our data set by one of those things. So we're asked to scale up our values for A by a factor of 5. So our new set, call it C, is going to be equal to times 5, 75, 60, 110, 80, 50. Okay, so we've got that new set. Let's reorder it real quick so that we have it from least to greatest. I probably should have left my A that way. But we'll do, we've got 50, 60, 75, 80, 110. Okay, that's our new set. Still equal to C, it's not a different set, it's just rearranged. So in this one, we actually, we do have the middle value, right? Because there are 5 data points. So middle value, 75. Median, x tilde. For set C is 75, whereas remember x tilde for set A was 15. So it seems to me that scaling up in this instance by a factor of 5 scaled up our median by a factor of 5 as well. And that kind of, I mean, that's fairly intuitive because we're working with a single value and it is among those that we multiplied by 5. So it would make sense that if we're identifying a single value, if we're multiplying that value by 5 and it's the representation of the set as the median, as our x tilde, yeah, it's going to be multiplied by 5. Now we're asked to scale up B by a factor of 3, and I just went ahead and did that. So multiplying each one of our data points in B by 3, we get this set D, 15, 18, 21, 24, 24, 24. Okay, now we're going to think about the median, the x tilde, in this set. So median of set B, recall, x tilde for set B. Remember we had those two middle values because this is an even number of data points. We had the two middle values, we took the mean of those, so we got a median of 7.5 for our B. So now let's do that with our new set. We need x tilde for set D. Middle two values, 2 on each side. That narrows it down to these two, 21 and 24. So I'll take my average, 21 plus 24 over 2 items. 45 over 2. 22.5 if we want to think about that in decimal form. What's the relationship between 7.5 and 22.5? Is it what we expect it to be? Yeah, it is. It is what we expect it to be. 7.5 multiplied by 3 is, in fact, 22.5. So we've got stuff happening just the same as we did with the mean. Our medians seem to scale up just the same as our means do. There is kind of a fancy little, while still pretty simple, way to prove algebraically that this is the case. If you guys want to see that, I will go ahead and show you that real quick. I want to show you because it's dangerous to take examples as proof, right? We don't want to think about examples as being proof of a principle, but if we can prove it in general, just using variables, then we can trust it. So I'm going to go ahead and prove this to you just super quick. It's not very difficult algebra. So this is what we assume. We assume that we have an ordered set of values, set A, and I've listed out arbitrary data points in this set. They're in order. And then XP is going to be the middle number. We may get the middle value. We determine that it's the middle value by just saying that it's the n plus 1 over 2 term. So we're cutting it in half. We're moving forward 1, so we know for sure that's the middle. So we scale everything up by multiplying by some factor A. We don't change the number of terms in the set. Not at all, right? So this XP is still the middle term in this list because it's an odd numbered list and we've defined P so that it's the middle. So this value AXP is still the median. It's going to be the median of our scaled set. So if I scale A values by a factor, capital A values by a factor of little a, it's going to scale up my median as well. Or down, of course. Take a minute and prove to yourself that this works by doing the division problem on your in-class exercises. I almost forgot to show you the odd case. So here's the odd case, or excuse me, the even case. I showed you the odd case. Now I'm showing you the even case. If A's are set, but n in this case is even, then in general, x tilde of A is going to be the average of these two values. So the middle value doesn't exist. We'll have to add up this one, xp and xp plus 1, where p is just half of n. So if we have a list that's 6 items long, then we're looking for the third and the fourth term. If it's 10 items long, then we're looking for the fifth and the sixth term, right? So that's what I mean by p being n over 2, and then p plus 1 is just the next one. So this is proof that if we scale up all of our values, all of our data points in A, by multiplying by a little a, this is the quick algebra that we do to show that the median also gets scaled up, right? So both of these two middle terms get scaled up by a, right? So we can use that distributive property again, just like we did with the mean, pull that little a out, and then we're multiplying our original median by a. So it works. That's algebraic proof. Now 1E on your in-class assignment just asks you to basically apply what we just concluded. We just concluded that by multiplying or dividing, hopefully you checked for division as well, by some factor or dividing by something, if we do that to each of the data points, then the median gets scaled up or down accordingly, right? So we're just going to apply that with this sample data that have a median of 14.4. If we divide each of those sample data values by 8, what do you suppose it's going to be? What are we going to get if we divide each of those values by 8 and their median is 14.4? I think we can draw some conclusions, right? We've already drawn the large conclusion. Now we just have to apply it. I think we've concluded that if we divide each of the values, then the median gets divided as well to give us the median of the new set. So if you take 14.4 and you divide by 8, I think that you're going to be able to get your new median, the median for your scaled set. Now let's think about what would happen with a shift. Your in-class assignment asks you to just make a guess here, right? So I want you to do that. Think about this before we go over an example. Consider it, come up with a guess, what you think might happen. Picture what's actually happening when we do this in your mind. Without even giving specific examples, without writing down a set, think of what's happening. Imagine like big picture, what's going on. Here's just a new set. I'm just going to use this new set with 5 values in it, 1, 7, 14, 6, and 8. Not in order, right? So I think a place to start, if we're dealing with a median, is definitely to put this in order, right? So let's do 1, 6, 7, 8, 14. Okay, so this has a median currently of 7. What if I shifted? What's going to happen? Is the order of the values going to change at all? If I take 5 away from each of these things, for example, or even just, we'll just do 5. Why not take 5 away? If I take 5 away from each one of these values in this data set, it's like I'm just picking up the whole collection and scooting it back 5 on the number line, but I'm not changing the order whatsoever, right? So whatever value corresponds to 7 is still going to be the middle. And what would I have done to 7? I would have subtracted 5 from it, just like everything else, right? We can see this here. If I did this to this set A, if I shifted it back 5, if I shifted by subtracting 5 from every value, every data point, I get this new set, -4, 1, 2, 3, 9, and middle value was 7, now it's 2. We just picked up the whole thing and scooted it back. So there was no rearranging, there was no change really in the relationship between the values, their distance from each other, anything like that. They maintained distance from each other, they maintained their order, and so 2 is still the middle. And without doing algebraic proof, because I think you guys know how this would look, it's probably, if you want to, prove it to yourself, please do. But I will just let you trust me on this otherwise. We can conclude that this is the case in general. If you imagine picking up that whole set, it is true in general for any data set if we add or subtract the exact same value from every data point. The value that the new value gets, the new median gets subtracted or added the same way. It gets shifted exactly the same as the individual data points did, and that's a general statement that we can make. I'll let you do your own calculations for the next problem on here. I'll let you go ahead and calculate what your median would be if you had a median that was 14.4 and then you subtracted 5 from each of the values. I'll let you apply this new knowledge that you have and solve that one on your own. So what do we think happens with midrange? Midrange, remember, deals only with that first value and last value if our set is written from least to greatest, right? So it's just the average of the largest and the smallest values. Let's just look at this set again. We'll look at our new set A, our 5-item set A. Midrange here would be the average between 1 and 8. So midrange of A is 1 plus 8 over 2. 4.5 is the midrange here. And that is 100% incorrect because I forgot that I erased my ordered set A. So let's redo this with set A in the proper order. the mid-range is, in fact, the average between 1 and 14, the two values on the ends of this set when it's an ordered set. So mid-range is 1 plus 14 over 2, 15 over 2, so 7.5. That looks way better and much more representative of our set. Scaling here is going to be really, really similar to what we did with median, because we're dealing with individual values, right? We're dealing with these two values in this set when we calculate mid-range. So it's almost an identical situation if we think about the algebraic evidence that this works. It's almost the identical situation as we would have if we were calculating the median of an even numbered set. Like if we had an even number of items in a set and we were calculating the median, right? Because we're dealing with two numbers, each one of them gets scaled up or down the same. So adding those scaled numbers up and then dividing by 2 is the same as adding them up, dividing by 2, and then multiplying by that scale afterwards, right? So we can see that by multiplying every data point in this set, we're also going to scale up the mid-range, right? Or scale down the mid-range, either way. If we're looking for a set of 5 different numbers whose median and mid-range are both 290, a good place to go always is those symmetrical sets, those ones that are kind of perfectly balanced, right? I definitely know that I have to start at 290 with my middle value of 290, right? Does it even matter what these are as long as they are on the correct side of 290? Only to a certain extent, because we have to pick these two values such that their average is 290, right? So that's going to be a little bit of a trick. We have to make sure that this one is smaller than all of the other values, or at least one of the smallest. And then this value has to be bigger than all the others, but somehow we have to make them meet in the middle at 290. I would say the strategy would be to pick those end values first and then fill in these two afterwards. So let's pick two values that we can add together and divide by 2 to get 290. Well, I might think, well, if I'm gonna divide by 2 to get 290, I probably better have a sum that's twice 290 to begin with, right? So whatever this is, and whatever this is, has to equal twice that, because when I divide, I get 290. So let's multiply on both sides by 2. 290 multiplied by 2. It's 580. So whatever numbers I pick, they have to add up to 580. I just know right now, all that I need to know is that this number x1 has to be smaller than 290, and this number x5 has to be bigger than 290, because I can always find something to go in between, right? So I don't know, let's just pick, I'm going to pick something small. I'm going to go ahead and go with x1, 100. I'm going to let it be 100. That allows me to make the fifth term 480. Now we just have to squeeze some stuff in between, and it doesn't even matter what those values are as long as they fit in between here and here, respectively. We're all set, because these values do not go into the calculation at all for median or for mid-range, right? I'm just going to pick something random. I'm just going to put 200 here and then 350. Who cares? It doesn't matter anyway, right? There's our set. This has a median of 290 and it has a mid-range of 290. The next one, where we're looking for a set of 6 values, 5 of which are the same, and 1 being different, so that their median is 290. There are lots and lots of ways to do this, and we're not even all that restricted, right? Basically, the only thing that we have to consider is that the middle value has to be 290. So I've got 6 items, but 6 items means that it's not actually a middle value. It's not going to be a point in the data set, right? 290 would have to be the average of the 2 middle values, right? We could accomplish that by just making them both 290. We could do that. So let's do that. If I want the 2 middle values out of 6 to be 290, that means that I want the third one and the fourth one, right? I need the third value and the fourth value to be 290. So 290, 290. I add up 290 twice and then divide by 2, I'm going to get 290. So that's my median for sure. We're set to go there. Now, it doesn't really matter what we fill in everywhere else as long as this remains an ordered set. So we can make one value different. Could be the first value. That's not going to change much. All the rest, 290. Why not? Or they could be anything else as long as I was able to squeeze that number in between here, between 100 and 290. But we were told to do them all the same except for the one. So everything's 290, including those 2 middle values which contribute to our median. What if we did something tricky though? What if we changed up that middle so that the 2 middle values are different? We just need the third and fourth terms to have an average of 290. So I could go 280 and then 300. 290 smack in the middle of those, right? If I add them together, I get 580, divide that by 2, that's 290. Now, I do have a choice to make here, and it matters when I make this choice because I'm trying to do 5 of the items the same, 5 of the data points the same. Can I pick 280? I can't, because that would mess up my order, right? So, It seems to me that we've stumbled upon something interesting because I have nowhere to go from here, huh? I can't choose my 280 for the repeated value because that messes up the order up here. I can't choose my 300 for the repeated value because that messes up stuff up here. So if I'm going to have only one data point different, I think I've just discovered that both of those 2 middle values in a 6 data point set have to be the 290. They have to be that median that I'm aiming for. So in keeping with medians, this next problem about test scores is kind of an interesting one. We're asked if 3 tests have been taken already, we have a 58, a 72, and an 84. We are asked what score we need to have to be able to bring that median up to an 80. Now, is that even possible? I guess the assumption might be that we get a higher score than 84 on this one? Are we hoping for higher than an 84? Does it matter if we get something higher than 84? Because where would 84 go if we get some higher score? If we get some higher score than 84, then 84 takes its place in this set right there after 72 as the third value in the set. We don't know what this is, but how is this median going to be calculated? Well, the median is going to be calculated as an average of these two, right? 72 and 84 get added together and divided by 2. 156 over 2. Uh-oh. This looks like a 78. So whatever this student gets, they could get 150%. They could do the test twice. They could get 200% on this test. They're never going to have a median that is greater than 78. And that is something that's actually really useful with a median. 200 would seem an outlier in this set, right? This person is not a very responsible test taker in general. They've improved, definitely improved, right? But got an F, got a C. They did okay on the third one, right? But a 200 would really drag up the average if we were to use, say, a mean to calculate a representative value for the set, a measure of center for the set. That would really drag it up, and that might not represent very well this student's ability. But 78, yeah, that's going to represent the student regardless of how well they do on that last test. Okay, now let's take the same set of test scores and let's think about the mid-range here. I think we can safely assume that the two lower scores in this student's set of tests are going to be the 58 and the 50 or and the 72. 84 could be here. Could it be here and have us able to get an 80 for the mid-range? I'm thinking not, right? Average between 84 and 58 would not be 80. So we need something bigger than 84 for that fourth test. Makes sense. So 84 is going to go here. So this question just comes down to figuring out what it is that we have to average with 58. We have to average with 58 to get an average, to get a mean of 80 if we're just adding up and dividing by 2 with those two values. So 58 plus what divided by 2 is 80. Well, just like with the mean question that we had on Monday, we can think about this as total points, right? If we're going to divide by 2 to get 80, that means we would have had to start with 160 points. So what is it that we have to add to 58 to get 160? Well, this person better get some extra credit, but they can do it, right? They need 102 points on this next test to be able to get a median of 80. Or not a median. We're talking about mid-range right now. We're talking about mid-range. Mid-range can be drug up if we need to, right? If we need to influence heavily a representative value, we can do that by putting one value in, right? That's that idea of outliers having a strong effect on, say, the mean, or we've shown they can have a strong effect on a mid-range as well. All right, guys, that's it for today. I will let you do your other things. Let me know if you have any questions. Discuss on the discussion board your homework associated with this in-class lesson should be posted, and that as well as A1 are due on Friday.